We are Team Driftmoto. Our project is a snow bike conversion kit. We kind of wanted to give you the layout of our presentation here. We're going to do a project introduction, talk about the voice of our customer, our project goals, and then we're going to break it up for each team member. And they're going to talk about their team role, their design responsibilities, their individual documentation. And we're going to come back and we're going to do a semester's outcome, and we're going to take any questions at that point. So my name is Wiley Collier. I'm the team lead for Project Driftmoto.
I'm Dave Johnson. I'm the estimator for the project.
Aaron Chapman, I'm the project scheduler.
Josh Harden, I'm the quality lead for our teams.
Brian Russell, I'm the team facilitator.
Stephanie McBride, I'm in control of documents.
So the voice of our customer, we use the Moscow method, which stands for must have, should have, could have, and won't have. And we just kind of went through and we talked to a lot of people, and those of us that have been around snowmobiling and the motorsports industry, we went through and decided, what should we have, what must we have, and what we didn't want on our kit. So this was really helpful when we were setting our project goals for the semester and for the project. So to be competitive, we needed to have a $5,500 budget. It needed to be lightweight because it's a snow product, so getting on top of the snow is important. It was important to have a fully functioning kit at the end, and we wanted to meet all of the deadlines either on time or ahead of time. Some of the key dates, obviously semester deadlines for deliverables for this semester and next semester, and then we plan on having our kit done by March 1st so we can hit some of the good snow conditions while they're available. Some of our design goals, we didn't want to reinvent the wheel on this project, so there's a lot of things involved on this project, like suspension geometries that people have devoted their lives to developing. So we kind of wanted to not start from scratch. So we implemented a lot of industry standard things. One of my favorite things is keep it simple, stupid. We just want to keep everything simple. And then obviously functionality and reliability are really important because you don't want to get out in the backcountry and have your kit break down on you. So again, my name is Wiley Collier. I'm the team lead for this project. Did we miss a slide? The video?
No.
And so some of my responsibilities for this project are project organization, scope, establishing the voice of the customer, setting the pace of the project for the team. We really wanted to dive in. This is a big project, and we had a lot of things we had to get done on the front end. And then obviously setting the team involvement levels. My design responsibilities, I had the subframe design, so the actual weldment. There's also another weldment, the tunnel, and I did the subassembly of the side plates with the subframe weldment. As far as documentation goes, I was in charge of the budget, voice of the customer, welding quality, and another major responsibility that I had was the funding of the project. And so we applied for and received a research grant. And we also have local sponsors. Some of my goals for the team are team unity. It was really important for me to get along with all the team members, as this is a very involved project. I needed all hands on deck. Another big thing is to have fun, and we do have fun as a team. You'll see later in our communication slides that we do get along really well. And as team lead, I kind of felt like I wanted to kind of push my role onto some of the others. And so one of my favorite philosophies for leadership is there are no bad teams, only bad leaders. And so I feel like senior project is a good leadership opportunity for everybody on the team, not just the team lead. And so everybody on Team Driftmoto is a lead for some portion of the project. So we have our scheduler. I'm going to defer to him for everything scheduled. So he has kind of his own ownership for that portion of the project. And so I felt like it gave everybody an opportunity to exercise their leadership skills. So some of my major sub-assemblies. So the whole kit consists of this here, and we broke it up into sub-assemblies. The frame, the drive, and the skid. And we broke it down into teams. So Dave and myself were on the frame, Aaron and Josh were on the drive, and Stephanie and Brian were on the skid. So this is the frame assembly that I put together. It's this part here, it's the weldment and then the rear weldment. And it's going to be 4130 chrome moly. The mounts at the front allow for any bike fitment that's a standard like produced bike, so Honda, KTM, Yamaha. And another key point is that the chromoly, we use the chromoly for the higher strength, so that would be lighter weight. Same thing with the tunnel lattice. It's kind of a different design. The tunnel is actually removable from the kit so that you could actually change the track length of the kit and not have to like buy a whole new kit. These are some of the design drawings that I did. One important thing to point out is, so the subframe is broken down into individual components. So when you go to manufacture that component, you have a single drawing for that single piece that will go into the weldment. And that makes for bend angles and the copes on the ends, so you can manufacture that piece to go into the assembly. So in this, we did a time lapse of our rapid prototype. We 3D printed it, and it's a full-size replica of the front portion of our frame that actually mounts to the bike. And this around. And we decided to go with the full-size rapid prototype so that we could actually fit it up to the bike and make sure it was going to fit. And we found that when we printed it, it was too wide. It was a full inch too wide. And so we went back in and I checked my measurements in my notebook. My measurements in my notebook were good, but when I did the weldment, you have to account for your tube width. And so by not accounting for the tube width, that dimension got pushed out a full inch. So we actually, through the rapid prototyping, solved the problem before it happened in the actual weldment. So it was really cool to see that tool being used in our project. Other portion that I'm in charge of is the weld design and quality for this project. And so make sure we size the right size tubing for the strengths. This here refers to a weld design book, and it shows that stacked tubular connections are stronger than singular tubular connections, and it actually makes the welding of it easier because you can't get, it's hard to get the welder in between the joints here. And so our kit will actually have quite a few stacked tubular connections. For our portion of the research project, we are going to be doing a weldability study comparing welding processes for the chromoly. We're going to be comparing gas tungsten arc welding to gas metal arc welding short arc. And so this is going to take place next semester at the very beginning. And we're also going to compare filler metals for tensile strength and fatigue life and weldability and ease of manufacture. So obviously like a gas metal arc with a solid wire is going to be the fastest in production. And so we're going to evaluate, for manufacturing, hopefully be able to rank those on which one is the best. There will be a welding inspection and test plan and welding procedures and PQRs developed for this project. And so I feel like my portion of the project was to really, get the team on board with the scope of the project, and then make sure we had the funding and get the research done and the design done. And I feel like as a team we've done that. And I'd now like to turn our time over to Dave, our project estimator.
Thanks, Wiley. I'm Dave Johnson. As I said before, I'm the project estimator. Some of my design responsibilities were the side plates, the drive cover and drive gasket. My individual documentation was safety and environmental, the router forms, JHA, cost estimate for the side plates, and then the cost estimate responsibilities I had was a make-buy, type 1, type 2, cost estimate form, bid sheets, and the indented bill of materials, which were also costed. So we worked together to build this bill of materials. We all kind of collaborated together. This is a indented costed bill of materials. And it shows, you can see here that we have it broken out into different hierarchy levels for the main assembly, full assembly, and then the individual sub-assemblies for each one of those. And it shows the labor costs that we put in there for all make parts. And then the material costs, and it came together for a total cost there. So the make-buy analysis I did on this was for the rear swing arm. I did a cost estimate using Stephanie's bid sheets, cost estimates, and then also her routers for time. It came out to be $202.13 for us to make it. Then we went down to triple ADS to price out just buying this rear swing arm, but you can only buy it as with the shock and the swing arm. So it came out to be $645 just to buy that. So it's quite obvious it'd be cheaper for us just to build that rear swing arm. The design drawings that I was in charge of, this is one of them. This is the side plate. I was tasked to make this a sleek but strong design. Also had to flow really well with Wiley's tube tunnel design he had. We're using the aluminum 6061 T6, and I think it turned out quite well. It flows quite nicely with that tunnel off the rear end. So we did the prototyping on this as well, using the plasma. We got together as a team, set it up, put the camera or a phone up on there so we can record it. You can see our cutout down here from this prototyping. After we got done with the prototyping, we did find a couple errors with the hole locations versus where our frame locations for those holes were at. So it was a great advantage for us to do this. This is another part of the project I was tasked to design. We needed a cover for the drive section that was low profile but strong, because there's a huge potential for this to be hitting rocks and trees. We had to make it strong but low profile so it wasn't sticking out so far. The cover is going to be 3D printed, and then the gasket will be made out of dense form, and we cut with the laser. I think overall this portion of the project went really well. We worked really well as a team together to build the bill of materials, and then also all the cost estimates all worked well together. I'm going to turn the time over now to Aaron.
So clearly everybody has the same question at this point, I'm sure, is how did this team orchestrate this project so well? So my role in this project was that of a project scheduler. So one of my roles was to go through, define what our tasks are, set time limits to it, and then help everybody progress towards those goals that we had set. In addition to that, some of my other responsibilities that I had, there were some individual documentation that I did, the ECO document. So you'll see, as we've mentioned earlier, we had partnered up and basically split these sub-assemblies down into teams of 2. I was fortunate enough to be partnered up with Josh. He's a phenomenal person to work with. But that being said, him being over quality, I found a lot of the stuff that I was working on documentation-wise flowed right into what Josh was doing. We were working together. It made sense for us to work on the whole project together as well. In addition to that, process flow chart, I was responsible for that, quality control plan, and then of course the make-buy analysis and things that I did on my own components. Like I said, part of the responsibilities I had was to maintain our schedule and make sure that things were moving forward. Some of the things that we did in this part that I'm going to talk about here now, some of the things we did were a little bit different than what the rest of the teams did. And so what I'll discuss initially is, in setting up the project schedule, we decided to change the actual software program that we were using, and we went with a suite called Team Gantt. There were reasons that we did this, one of which is, as you can see, the very first bullet point is it's free. We're college students, we don't have a lot of money, so. That being said, we went with Team Gantt. In reality, what I have found when it comes to Gantt charts is most of the time they're an obligation, not a motivation. The problem I have with that is I didn't want this to be something that we were always having to go in and be reminded, oh, we have to update the Gantt chart. In reality, what I wanted was something that was actually driving us and directing our work. Some of the key advantages that Team Gantt has is that, as you can see in this, in the prior slide here, you'll notice that this is actually a web form. So it's actually an online-based Team Gantt chart. So the nice thing about that is each one of these team members, they can actually go in, update their own progress, and it just simply required me to manage what the tasks were and when they were due. From that, the other nice thing about Team Gantt is that it gives you, if I can jump back to that next slide, it does give me email notifications. Some of the interesting stats that I had on this. Through this semester, I had 73 emails sent to my account, 174 individual updates as far as what these guys were working on. The thing I did find is that the majority of those emails were usually sent at about midnight, so you can tell when college students are most productive, is usually later on. So, the other thing that it offers is at a glance you can see what your available resources are, who's overburdened, who can I tap into and use some of their resource in order to help out one of the other fellow students. That being said, let's go ahead and jump into the components that I was responsible for. So, like I said, I was partnered up with Josh Harden, who you'll be pleasured to hear from here in just a minute. The drive components that I was in charge of consisted of the brake assembly as well as the chain tensioner assembly. The brake, we decided to go with a couple components that literally we could just buy off of the shelf. We went with the 200 millimeter rotor. You can buy that off the shelf. We went with the single piston caliper. You can also buy that off the shelf. What it did require us to produce is the brake rotor hub, which that was made out of a 6061 T6 aluminum, mainly for the strength and weight that we would get out of that. We did use keyways to isolate that to the jack shaft in which it installs to. The other part was the brake caliper mount. That was also made out of a 6061 aluminum. The other component that we had that had some key features to it that were super important is we went with the chain tensioner. There's a lot of different designs out on the market as far as how they are tensioning the drive system, whether it's belt or chain, between the jack shaft and the drive shaft. What we decided to go with was a simple snail cam design. It's lightweight, it's strong, it's low in profile. You saw from the other drawings as far as like the drive cover, what we wanted to do was make sure that we stayed within that profile and didn't interfere, so we could keep it as low profile as possible. From here, this kind of just reviews some of the key points that I talked about. Things it does include is what machines we'll actually be using to produce these, as far as that goes. And so let's talk about some of the calculations that we did on the drive subassembly. One of those that was probably, I would say, one of the key factors was our bearing selection. Major concerns that we had with that is it obviously had to live up to the demand of what this machine is going to do. In doing these calculations, what we found is that the max RPM would be that of the tensioner itself due to it being a smaller sprocket than the jack shaft and the drive shaft, which it was just over 10,000 RPM. The bearing that we selected is more than capable of that in that it can handle 18,000 RPM at a constant rate. But some of the other calculations that we're currently working on is we do want to calculate the impact loads throughout the drive system. And then in addition to that, we also want to do a fatigue life calculation on both the jack and the drive shafts as far as that goes. What I would say is that in summary, as far as the project scheduling that we did, I would say it was very successful. You can ask any one of these teams. The software suite that we decided to use definitely helped us to refer to that and help it drive our actions rather than it simply be a task that we always felt we had to go back and update. As far as the design components, I found myself intertwined with each and every one of these team members, going back, making designs and changes and things like that until we finally released our finished drawings. So that being said, I'll turn over the time to Josh to discuss some of the other drive components that we had to produce.
Alright, so I'm Josh Harden, like I said earlier. I'm over our team quality. Some of my major responsibilities, more specific to design, is to manage our top level assembly and kind of be the design go-to. So just help where I can, and my background more emphasizes towards that, but along with manufacturing. So my individual parts that I was over was the jack shaft assembly and the drive shaft assembly. And I'll get into that a little farther in the next slides. But some of the individual documentation that I was over had to do with the manufacturing process sheets for our mills and our lathes. So when we decide to make some of our parts. I also did a couple of our design for manufacturability analysis as far as the part coming together as a whole. in case of our capabilities that we have in-house and where we can outsource. I also did an FMEA analysis on one of our major components that will have a direct impact on our drive system. And then, of course, the drive routers and cost estimates for all my components. Some of the team quality documentation that I worked on with my teammates was the quality plan, process flow chart, and the inspection sheets that we will use for all of our parts. Okay, there we go. So just to give you an overview of our quality plan, the ECOs will be the primary tool used to drive all the changes across our entire project. So right here, our ECO form has all the essentials as far as having the part number, a description of the change, and some of the reasons for the change as far as, what can it affect downstream. And then from there, of course, you have the signature approval process that we go through. But all of our components will go through this process flow chart as far as from the top going down. We will basically have your part, it gets its router and process sheets that goes into making it, and then from there it's manufactured and then inspected. From the inspection, we look to see if it's going to be conform to the print. From there we make a decision. If yes, then we'll use it. If no, then we go and work as a team as far as an MRB initiative, so material review. And from there, we review the non-conformance and issue an ECO if necessary for our design. Right here is just two examples of our inspection sheet that's essentially standardized throughout the manufacturing of all our make parts. And once again, here it has all of the necessary information as far as part material, the finish, and critical characteristics to each. With the FMEA analysis, as I said, I chose a part that we put some emphasis as far as it's critical to our snowbike kit, and that was the chain tensioner. So with the chain tensioner, its primary function is to provide tension for our kit. And from there you have the potential failure modes, which could be from chain breakage, tension or slippage and corrosion, and a couple others. So if you go down to another level, just to kind of zoom in on that, for example, you go through and you analyze the risk and severity and then the occurrence or detection. And from there it's assigned a risk priority number. From that risk priority number we're able to filter through, what are some of the features on this that needs to be addressed. From there we recommend some action, assign it to some of our teammates, and from there the action is taken to bring that risk priority number down within an acceptable range. Right there you can see that it was 350 and dropped down to 140, which we deemed was okay. As I said, I'm over the drivetrain assembly with the two major assemblies as far as the jack shaft and the drive shaft. Some of the key features of our drivetrain assembly is how we're transmitting the power, which will be through key stock and keyways. There's multiple reasons we went with that. Number one was for the design for manufacturing, just taking in our capability we have in-house, along with just the ease of manufacturing with that. Our drivetrain has a 1-to-1 ratio as far as the 3 17-tooth sprockets. Our shafts will be machined from high-strength steel. Just going back to our end goal, we're not trying to reinvent the wheel. We kind of want to do what's similar to our competitors, just because that's what the market demands. And then just some additional information on our bearings based off of Aaron's calculations that he did to just get some dynamic and static loads and once again our max RPM. So here's the three major assemblies I was over. So like I said, I was over the exploded assembly, top level, and managing that from all of our teammates. From there, I have my exploded assemblies of my two sub-assemblies. Our template, I don't think anyone said, but Stephanie did great work on that. She managed the format and template for us, so it's all standardized throughout our team. And just going down one level farther, here's two examples of some individual parts that we are going to make in-house. The first one being the drive shaft, which will be made from 4140 steel. Some of the processes that we're going to use to make that is turning on the lathe and milling the keyways. And then some of the benefits of just the material selection is the high strength and durability. And then just another example of a simple part would be our bearing mounting plate. Just made out of 1018 steel. Just can knock that out on the mill, and just ease of manufacturing will make that happen. So some of the process engineering documents, just to get a little detail on kind of where we went with that. So right here we just have all the essentials as far as the machining it and inspecting it and then storing it. From there we got our cost estimates. Our form is based off of Rick's form for cost estimating. We've kind of tweaked a little things more incorporated towards our team goals. And then just an example of a bid sheet. overall, I feel like our team is on track. I know as far as my individual components, everything's on schedule, and I'm just excited to get to actually doing the fun stuff and making them. So just hand it off to Brian.
I'm Brian Russell. My role was on the team as the team facilitator. So with that, my major responsibility was over the communication of the team. Communication amongst our team and really any team in the industry is probably the #1 most important thing there is within a team to get a project successfully completed from start to finish. And so as a team, we met regularly. Every Monday morning we met to, in our Monday morning meetings, we set aside to go over our team Gantt chart and review our schedule for all our tasks that was coming up and anything that we were assigned to, and then we would make assignments going forward. And so that would take a chunk of our meeting, and so the rest of our meetings, and have our meetings really beneficial and so we can cover all the topics that needed to get covered, I was assigned to make the meeting agendas. So I would take the 3 or 4 items that we really needed to get covered and make sure that they were on the weekly meetings so that we could stay on task with our last 30 minutes or whatever of the meeting to make sure they got covered. And because it's easy to get off track and not get anything accomplished. And with that, I also kept track of the meeting minutes, and we would review those the next meeting. We would review the minutes that we had from the previous meeting and review the assignments that we had in those. That would conducting the meetings. A little more with communication. We have 3 really important modes of communication that we used. Aaron touched on the one just a minute ago of our team Gantt. And the other thing that was really nice about that, like he was saying, but we were all administrators to this, so we could go anytime, day or night, as long as we had a device that we could connect to the internet, just go in there. If we wanted to review the schedule somehow, if you had a certain task you were wondering about, a deadline or something, you could get on there. And like he said, you could get the notifications that somebody had just made an update or you have a task that's due tomorrow or whatever. And so that was a great communication tool for us. Another one was our Google Drive account that we had set up. And we were all administrators on that. And what was nice about our Drive account is that all of our assignments, we had documentation that we were in charge of producing the forms for, and all of our individual parts, our designs, we could work on those. We could upload them to the Drive, and if anyone wanted to reference something, like Stephanie and I, for instance, we were working on this skid rail subassembly together. She could upload her parts, I could upload mine, and we could I could download the stuff that she was working on, and in SolidWorks fit my parts, components to hers, and get them to match up, put them back up onto the Drive, where Josh could take the most recent updates that we've done and compile the top level assemblies. So our Drive account worked great for that. And as we were filling out our router sheets and process forms for everything, we could go in there, pull it out, complete them, put them back on there, and like I say, any member of the team could go in there and just see the most recent revision of any one of our forms with that on that Drive. Another mode that we chose to do was the group text. It's our main. We all have cell phones on us all the time, so we would do all of our communications whenever we wanted to have a meeting or something, or just a question on something. We could group text it, and everybody could get involved with every part of our project. The other thing with working with Stephanie, on one of my components, when I made it up to make sure our components fit up, one of my components didn't match hers very well, so it was easy to fit. I just had this most simple part of my assembly was a shaft. I had just a 1/4 inch too long, but since I was able to pull it off the Drive, Stephanie's components to match on mine, I was able to make the change there and put it up there without having to meet with her and get her drawings from her. and that really helps out Josh too. So like I said, I was tasked with Stephanie over the skid assembly part of our assembly. So Stephanie did the front and rear swing arms there, and my part was the lower suspension parts, the slide rails, the bogey wheels, that idler shaft there, and the connecting shaft that connects the slide rail assembly together. And so for the bogey wheel shaft and the connecting shafts, we're going to be building those parts. One of the most complicated parts in the whole project design that we have is this skid rails right there. And we've been going back and forth on make, buy, because they're probably the single most expensive individual parts on the set. We were looking at doing it here. We don't really have the capability to make that in one step here. We'd have to build a multi-purpose fixture and several steps, and so we were looking at the outside machine shop to do it for us, and they were kind of the same way. And they were quoting us about $750 a piece for those two rails to build them. We can buy them for about $500 from Polaris, but we've been talking recently too. We're talking about maybe doing some other ways to be able to produce that and manufacture that part here. But we're making some significant design changes, but we'll get more into that in the next semester. Some of my drawings, my components, again, there's the slide rail assembly there on the left or on the right, and the bogey shaft assembly is the one up on the top, and then there's our this one on the left here is the shaft that we'll be making that here. And with that, overall the communication of our team has been awesome. I mean, all the modes that we use to communicate, and with that Team Gantt and our drive, it just makes it so nice to work on this project and makes it a lot easier. We haven't had to meet as often as we would if we didn't have those means of communication. And with that, I'll turn the time over to Stephanie.
I'm Stephanie McBride. I am over documentation. I am responsible for putting all the documents and drawings in that big binder over there. I am also responsible for organizing it, which was a fun task the other day. I had all my papers sprawled and trying to figure out where each one goes with, because I have OCD over things, which is probably why I'm in charge of it. I was also in charge of creating a standard template for all of our drawings and our assembly drawings as well. I was also in charge of the naming standard for the parts and drawings. So what we did is, as an example, each drawing, the first letter is split up into A, B, and C. And A corresponds with frame assembly, B is drivetrain assembly, and C is skid assembly. So I have some examples over there. So the A, B, C, and then the next three letters are actually for the description for the part, and then the O1 is our revision. And so my individual responsibilities were to design the front and rear swing arms. This is a drawing of my rear swing arm. This is one that we've kind of gone back and forth on buying, just because it is kind of a hard part to make, and there's just a lot of components to it. And then I was also responsible for creating a process sheet for the tube bender, and then making a detailed bid sheet for my parts, and also just the template overall. I was also in charge of doing the routers and cost estimates for both the rear and front swing arm. And so as you can see here, here's my rear swing arm is, oh, there's a laser over here. That's my rear swing arm, and then that's my front swing arm. They're made with 4130 chromoly, and then I also have the anodized aluminum shafts, and then we are using the Fox Zero Pro shocks for both the front and the rear swing arm, even if we end up not buying them separately. And then here are my drawings. As you can see, this is my template that I made. I just put our nice little logo in there and then standardize everything for that. And so this is my weldment for my back swing arm, and then my full assembly for my front swing arm. So overall, I think our documentation went well. I got all the papers and documents that I needed for that binder. So, and I think I organized it well, I hope. It looks good to me anyways. So I will turn.
So let's talk about some of the things. I would say that we did differently, but actually that worked really well for our team. One of those is that we did very much have what I would call a decentralized command. Really what it came down to is each subassembly group owned their product. And that being said, it really didn't require Wiley as a team lead to be hounding everybody. It really was design your components, make sure that they interface with the rest of the team, and at that point everybody kind of owned their piece of this project. It worked really, really well. That gave us the empowerment to make decisions. The snail cam, that was simply a decision that I decided to make. It's low profile, it works, it's simple. It wasn't that, hey, I want to do this, guys, what do you think? It was a simple, make the decision, let's move forward and find out what we need to do next. The design teams, that worked really, really well. By taking this kit and breaking it up into what we consider the 3 components that really contribute to what it is, it was a genius plan to break up the team and say, okay, in groups of in groups of 2, let's have you work on this subassembly. That actually worked really well for us. The schedule, being over the project schedule, the thing I will tell you is that is probably one of the more difficult things. I could have spent this whole semester chasing people down, telling them what they needed to do. Having a place that they could all go to, see what's required of them, and when their tasks are due, I would say was probably one of the biggest driving factors that helped us be so efficient as far as getting these things done. Let me talk about something a little bit differently. I'm actually going to take this group right here and I'm going to kind of rearrange them. Josh, I need you over by Wiley. Steph, you're going to be an island unto yourself. It's probably one of the only times that it is proper to categorize people by their color. But in reality, if you look at this group right here, now I can tell you exactly, based off of the people code that we used, how I need to address them. I can tell you that Wiley and Josh, they're very data driven. They don't care about my emotions. They don't care about how I feel about the product. They simply want to know, what is it? When is it going to be done? That's all I need. Thank you. Move on. These guys, I legitimately will say, they are the guys that make the impossible possible. They keep the project moving forward. They are very directed. They are very efficient. When you look at Brian, Dave, and myself, we're what you would consider blue. Team camaraderie is probably one of the most important elements to us. Everybody needs to work together. The interesting thing is, and I'll give you the scenario of myself, is that each one of these people has a backup color that classifies them as something else as well. You have your primary color, mine being blue, meaning that I want to work together as a team, but my follow-up color, which is right after blue, is red. And basically what that means is, hey guys, let's make this decision, and then when the decision's not made, that's a point where I shift to red and say, okay, here's the decision, move forward, let's do this and get it done. It's interesting because you can see that throughout this group. Dave and Brian, I relate to them very well just because I know how they think. Stephanie, if I could sum her up in 2 words, she is brilliantly silent. White people, you have to pry information out of. The interesting thing is when I say brilliant, I literally mean she is brilliant. There are often times that I would find ourselves in a meeting, the answer's there, Stephanie has it, and it wasn't until somebody finally says, Stephanie, what do you think? And then the whole solution to the problem is laid out in front of us. The one thing I will say, if you look at Tuckman's stages of small groups, they typically go through 4 stages. That of the forming, storming, norming, and performing. By doing this exercise, we literally bypass that second step, which a lot of groups get tied up into. I don't know how I'm supposed to address this person, and so a lot of times you find that conflict there, but being able to see what these guys' colors are and what their expectations are, very quickly I know how to address them, what they need from me, and how to move the project forward. The last thing I would say that worked very well, and I know that we've come back to this time and time again, was Team Gantt. It worked very well. It was something that we did different, and I felt that it was a very large success. So In summary, these are some of the things that we did do differently that I felt really made this group bond, work well together, and actually relieve a lot of the stress that you typically find in a senior project. That being said, I'll turn the time over to Wyatt.
So some of the lessons learned or outcomes from this project, things that I would do differently or we would do differently as a team. Quicker design, spend more time doing the prototyping. We learned that stage was so valuable for us because of the rapid prototype and the side plate. We ended up making changes to our design. It was so valuable. I wish we could spend more time in that phase. About a quarter way into the semester, we got into a routine of a meeting on Monday, a meeting on Thursday. Everybody was there at 7:30. We'd talk about some stuff. And a lot of times we'd walk away and we had got nothing done. And so we actually, as a team lead, I sat down with each member of my team and said, hey, what is something that we could do differently? Let's kind of evaluate. And it came back that, hey, we need to have more productive meetings, and it would be beneficial if I had more time to work on things on my own. And so we tried to cut out our Thursday meeting unless it was mandatory. And so based on our Monday meeting and what we had got done during the week, we would decide if we needed to meet Thursday or if we just need to work on stuff Thursday. And so we actually cut down our meetings, and it forced us to have more substance and meaningful meetings on those Monday meetings. And I attribute that to a lot of us not killing each other in the middle of the project because we were having worthless meetings that didn't accomplish anything. The other thing I think we would do differently, we all get along so well. I wish we would have done more things outside of senior project together so I could get to know them better. Like I can honestly say, I would love to hang out with anybody on this team at any time. Some of my best friends have been made on this team now. So the other thing we wish we could have done is spend some more time one-on-one with customers who have snow bikes, getting voice of the customer inputs, things that we could do differently with our kit. And I also wish that we could have taken everybody out and ridden a snow bike so they know what it's like. I think that would have been valuable input for what would have been good for this project. Our plan for next semester, obviously we need to get our welding testing and qualification done before we can build anything. We are going to order parts. We have a schedule that we're going to order those to, and we're going to try and get them in the door quickly so that we can get the manufacturing going. We are designing a weld fixture for that critical subframe because everything bolts to the subframe, and so some of the tolerances on that are going to be controlled through a fixture so that we don't have any warpage and shrinkage on that fixture while we weld it. We are going to concurrently manufacture some of the sub-assemblies, so this is going to go together really fast next semester, and we are hoping to be trial running this kit by early March next year. So we skipped a video at the very start, and I'd like to show it to you guys. So that's what drives Driftmoto right there. So we're all pretty invested into the motorsports industry, and I mean, watching a video like that just fires me up. So anyways, we'll take your questions now. Tobin.
What would happen if you took your schedule and compressed it and finished up by the third week of March? And let me tell you why. I think this is a perfect project to take to West Tech. West Tech is a manufacturing challenge in Los Angeles, usually about the second or third week of March, which is just right slightly after the spring break. We've gone there several times in the past, and it's sponsored by SME, the Society of Manufacturing Engineers. And they have a challenge and a contest to where they want you to do something that's manufacturable. You fit right in there. They want you to do a formal presentation just like you're doing here, and then show how something is a doable kind of a thing that you can take there and show off some of the things that you can do here at the university. And I think you just fit in perfect. So I'd like you to consider that real seriously. See if you'd like to go there and compete that, and I think you guys can win it. And I think you can do very, very good in it. And it's such an experience for you. The people that went to FabTech this year in Vegas, if you talk to them, they got some very, very good experiences out of that. And I think you guys could get some experiences out of West Tech that you would just remember for the rest of your life. It'd be a good thing. Think about that.
Being the project scheduler, what I can tell you is yes, we'd love to compress it.
I believe in it second, but I just want to say I enjoyed the presentation. You guys are well prepared, and it's always nice to see that first semester project be so prepared. So that was quite nice. Just want to give you a compliment. I did have one question on your calculations, and that was your keyway for your drivetrain. I didn't see the calculations there. Is that your failure point? Is that your design for failure at that point?
Yeah,
And why,
so that's
why,
one
why
thing.
keyway not spline? I guess
So the main factor in that came on choosing, and ideally we want a spline shaft and spline components, but just due to manufacturability as far as what we have here and just the cost of getting that outsourced, that's why we went with the keyway and key stock. We're actually going to have our keyways machined at Williams International. They actually just confirmed that they'll sponsor our project as far as doing that on the EDMs. So that's another factor that kind of came into it, is as far as manufacturing will be covered on that aspect.
And did you cover the calculations of that and what design?
But yeah, so that's actually one of the key items that we didn't address it in our presentation, but that is one key calculation that we are going to analyze as far as machine design goes.
Okay. Just a curiosity.
Yeah, two questions. So first question, then a follow-up. Okay. Those who have spent a day on a snowmobile and also a day on a snow bike, what are some of the advantages and disadvantages? What you would rather do? If you had the choice, take a date out on the snow or do it yourself, I mean, what would be some of the advantages or disadvantages of both? Why
So the difference between the terrain you can ride, the snowmobiles are going to handle the deep POW and they're going to climb the big hills just because of the horsepower and the traction they have. We're running a 120-inch track. Some of the big mountain snowmobiles are running a 173. And our track is actually cut down. It's 12.5 inches wide, and the snowmobile track is generally 14 inches wide. But because snow bikes are so, like a high horsepower sled's gonna be right around 150 horsepower. Your average dirt bike's gonna be about 50 horsepower. And snowmobiles have the centrifugal clutch, and so there's some advantages there. But like a snow bike, I'm gonna go ride the tight trees. I can get in between the trees. I can side hill all day. So where a snowmobile is gonna go straight up a hill, a snow bike is gonna go kind of cross slide the hill. But if you ever side hill on a snowmobile, you got to stand on one side and you got to get one ski up, and so it's a lot of work to side hill on a snowmobile. A snow bike you can side hill all day because you're just leaning over. So totally different like riding styles, and so me personally, I'd love to have sleds and snow bikes. And those big POW days when I just want to go climb hills, I'm going to ride the sled. The days where I want to go explore and have fun on the way to the good riding, I'm going to take the snow bike and go through the trees.
It's like the difference between a four-wheeler and a motorcycle.
Yeah, exactly.
So if you do take Kerry's invitation to do that, maybe you want to put something like that in that to make sure that that's part of the presentation, and especially to highlight, the greatest powder on earth.
Yeah.
That was my follow-up question.
So Aaron has a friend that started a business, and we're going to partner with them a little bit to do some videography when we go do our.
They'd like to come do a photo shoot as far as that goes. He manages a forum as far as that goes. And so as we go through and we're building this, we literally plan on professionally documenting the build phases. Part of that, you saw the time-lapse videos that we did. Part of the reason that we did that is we simply wanted to start at the very beginning. As we were designing and producing this, we wanted to document that in a way that most people find interesting. I'm always fascinated by watching a time-lapse video. It shows things come together very quickly as far as that goes. But Yeah, that is one of the key points that we plan on incorporating next semester, though we didn't put it in the presentation. Pretty much most of the presentation will be professional photo shoots.
Well, my follow-up question is a criticism in a way, because all the other presentations had a significant acknowledgement about the faculty advisor. Obviously, your faculty advisor was totally non-existent. Or didn't
Faculty
contribute.
advisor is a red, by the way, as far as the people is
He
concerned.
didn't contribute a thing. He didn't show up to any meetings, right? He was a real loser, obviously. But thank you very much.
If I could add a note there, we literally had planned on doing a 70s picture of your face and then us being like the children. We should have done it.
Next semester.
Wow.
He's already retired. anyway.
Is humility a red quality?
By the way, he gives you a grade.
He's got your binder.
So are you guys basing all your strength off full penetration welds?
That's a good question.
Yeah, you might want to train that welder a little bit. Lacking in here. No, but I did look at this from a weld perspective. Are these all weld joints on every single?
Yes.
You're gonna have to re-look at how you do those because half these you're not gonna be able to weld.
So I thought about getting like a pencil TIG torch. So there's some difficult welds on there, that's for sure.
Getting right up under here with a TIG is gonna be near impossible to get a full pen without having to gap that really badly. This area right here, we're gonna the overlap. They're gonna be challenging.
So, but if you look at the tubular connections, the joint strengths, like the welds are so much stronger than the wall of the tube. Like you're actually literally crushing the wall of the tube if you like impact that. And so where you stack those joints, you have that additional weld metal.
Well,
I agree. No, I think we need to. That's still part of what we're going to do over the next few weeks and over the first of the semester is evaluate the weld design portion of it. So because we ran into a time constraint.
What's your wall thickness on all this stuff?
120 on that front mount tube, that 1.25 inch one. Nope, that's the one up there. And then it's 1 inch, and we're gonna either go with like a 052 if we can budget. But if we need to go with a heavier wall, we'll do like a 083. So, like I said, we are gonna do some
We do
digital
have that
testing.
laser welder showing up in a few more weeks, and you'll be able to shoot narrow gaps and get full pen welds.
Perfect. We'll just laser weld the whole thing.
That's what I like to hear.
Yeah. We all over that.
That'll ease some of the issue here.
Okay. We are going to refer to our in-house Dr. DeCouster for some of our weld design.
Well,
I have a question. Where are you bending your pipe?
So we have the tubing bender in the machine shop, and we have 1 inch dies for that. And then, like, if we have like 3/4 inch or 1/2 inch that needs bent, we'll just use like a traditional tube bender because the walls is thin enough. So I do have access to some tooling for that. So.
we can just read it.
I put a question on here. Are they biting off too much?
Yes.
I've been the advisor for several projects of this scope, and it's very stressful. And to add the stress of getting ready by March, scares me.
So part of what Brian talked about and Stephanie, we are working the budget right now to see if we can purchase a few of those suspension components to ease that burden. So, because those are like, honestly, I don't want to mess with suspension components because you could screw that up really quick. So we are working on purchasing some of those.
It also sounds to me like it's an easy decision to buy the $500 Polaris skids versus make your own at this point. Why recreate the wheel?
Yep,
Exactly. That's our end goal.
Mark?
So I didn't see any welding symbols. Is
Yes.
this gonna be welded or?
We're actually gonna silicone it together.
Super glue.
Is that
We're gonna silicone it together.
silicone?
Mark, it's right here.
So like I said, we're still working on like the weld design portion of it, and I didn't want to throw out, like I could throw out a guess size of the weld, but I didn't want to go through those calculations, and I'm going to be working on that this week. So as you can see, we've purchased some chromoly. We are going to go through some testing. I'm here next week, so that's going to be working on next week, honestly. So. Rick?
Question, I know in your budget it looked like you were gonna have a shortfall over $1,000. Is that, are you guys
So
going to deal with that?
So we went and I went to ADS and I went and put all of the purchase parts through ADS, and that's like with their dealer markup. I am working through some avenues to get some of that dealer markup like donated. And so that was like worst case scenario. And there's an $1,100 fit kit for the bike on that, which includes one of the shocks. Whereas there is a solid strut fit kit that is $300 instead of $1,100. So that was like worst case scenario. So
So you guys feel confident you can pull it off with the money you've got or the deals you've got going on?
yep, I think, and we've gotten materials donated. Nucor's going to donate some plate, and we've got some machine that's been willing to be donated, and so we're working the avenues that we know. So,
When I say I do have one call, I like your schedule, I like the group participation of the schedule part. And that's a good point for a small group. It's much more cumbersome with Microsoft Project to do that. I would like to see a bench line, or at least a benchmark, some kind of a baseline that says, here's what I'm planning versus what I actually did. So then you could critique your scheduling or your guesstimating ability. And at least the status of your project might be a little more meaningful. Then we can holler at you for missing deadlines that you promised beginning of the semester.
People performed what they're graded on or rewarded on, so I reckon that makes perfect sense.
Yeah.
Be cautious on the donations, because the donations are going to go to an individual. It's going to, one of you is going to end up with it,
yes.
not Weber State University. And we've had that trouble in the distant past, way before any of these folks here, to where a company donated thousands of dollars worth of materials to what they thought was Weber State, and individual people took those. When the company found out about that, there were some serious ramifications for that. So be careful that, yes, you can mention Weber State, but it's not going to them.
It will not remain here. Yeah.
Okay.
Yeah, valid point.
That's good, we have no room anyway.
Yeah. Andrew?
So rumor has it that there's another snow bike team. Is yours gonna be done in time to actually ride on the snow?
Absolutely.
Because remember, whichever team wins the race is the one that gets.
So if you have it done by the 1st of March, you can take it to LA and 2 weeks later, and there you go.
Write it in the sand.
Remember what I told you, if somebody wants something, always negotiate.
Yeah. Maybe some additional funding.
Yeah.
Also, a word to the wise, when you get it running, don't drive it up through the grass.
Yeah, we've been talking.
Come on.
We've been talking.
That was our plan for a video.
But it'll be professionally documented.
All right. So we can all go to jail.
Just don't show it to the facility people, right?
They tested their snowmobile after they drank about 15 monsters in the middle of the night and cracked the case with a rock. The video was black.
That's frowned on.
Next day of senior project presentations.
Good for the white on.
Yeah.
I think we should give them a hand.
Yep.